All right. Hello. Okay, so in this video, we're still going to be rearranging equations. These are going to be a little bit tougher than the ones in the first video about rearranging equations. And I'm going to do three different ones for you guys today. I'm going to do some without any numbers. I'm going to do some with numbers, some with letters. It's still going to be roughly the same type of process. We're going to be using inverse operations to, in this problem, isolate and solve for x. Okay, so in all of these problems, you're going to see an x. And in all of the problems, we're going to have x is equal to something below. Okay, so I'm going to work with these first two, and then I'll get to the third in a moment. So in this one to the top left, we have 2 parentheses, x plus a, and when we have parentheses, that means multiply, so there's really a multiplying symbol right here. 2 times x plus a equals y. So we need to isolate for x. Now, some people might actually want to distribute this in, and that we could do, but there's actually an easier way to do it. So I'm not going to distribute. What I will do is actually, since x is a part of these parentheses, I can actually divide both sides by 2 right now. Because I want to get rid of this 2. I don't like that 2 on the left side, so I can actually, that goes away. So I have x plus a equals, now we have something new on the right side of the equation, y divided by 2. Okay, and now we're actually so close to getting x by itself right now. The only thing left on the left side of our equation is this a. So let's get rid of the positive a, and let's do that by subtracting a on both sides. Okay, so on the left side of the equation, we have x equals, we have y minus 2, so we can drop that down. Y divided by 2, we can drop that down. And what do we do with this minus a? Well, we can just say minus a. There's really not that much need to complicate problems like rearranging equations and isolating variables, okay? So our final answer is x equals y divided by 2 minus a. Let's try to tackle this problem on the right, our second problem. I still want to isolate x. I still want to get x by itself. So I'm kind of concerned about this divided by a part right here. Since a is dividing x, I need to get a away. So the inverse of dividing is actually multiplying. So I can get rid of this a by multiplying both sides by a. That will cancel out the a's on the left side of the equation. And I can rewrite this with x equals y minus z times a. This is a good solution, but if you want to be really correct about this, you can say y a over z. Because when we multiply y times a, we'll multiply those on top in our numerator. Okay? So this is our final answer. All right, I have one last problem to get to, so I'm going to clear this. My goal is to still solve for a. Solve for x, excuse me. And the problem I'm going to do looks like this. 1/3 times x plus 2y equals 3z. Okay? So I really want to get rid of everything except x on the left side of this equation. Okay? So the first thing I should do is look at the values and terms not associated with x. So I'm going to subtract 2y from both sides and rewrite my equation. It should look like this. 1/3 times x equals 3z minus 2y. Okay, so now I have this 1/3 here. That's going to be an issue. So 1/3 times x. How can I get rid of this 3 in the denominator? We worked on some of that yesterday as well. If I wanted to get rid of the 3 in the denominator, I multiply both sides of the equation by 3. Notice how I put the entire right side in parentheses because I'm multiplying it by a value of 3. Okay? So if I'm going to rewrite this, I can say these 3's cancel out. And now I have x equals 3z minus 2y times 3. If you want to distribute this 3 in, you can totally do that. You can say 9z minus 6y equals x as your final answer.